coverage of Boeing's pad abort test. We are coming to you live from the desert out at the White Sands Missile Range in New Mexico. I'm NASA's Dan Hewitt, and I have the privilege today to be joined by Jessica Londa with Boeing for what's going to be a very exciting and dynamic morning.
That's right, Dan. It's an absolute pleasure to be out here with you. I mean, it is such a beautiful morning today out at the desert. And
could be a little warmer.
It could definitely be a little warmer. We were struggling a couple of days ago, weren't we? But we just could not ask for a more beautiful morning for Starliner's very first flight test, pad abort, which is really one of the last major milestones ahead of crew flight.
And there's going to be a lot of stuff happening really quickly. And again, it's going to be a really dynamic test. So let's kind of paint a picture for what people are going to see today.
Yeah, so at this point, we're about 9 minutes away from liftoff. And Dan and I here, we are about 5 miles west of the test stand. And the Mission Director Center is another 500 feet or so west of us. So we did our launch minus 30 poll about, 20 minutes ago. All good. All goes across the board. The wind at this point, that windsock over there behind us is really barely moving. Wind slightly out of the east, so we are looking really good.
And there's a couple of key objectives that we're going to be looking for today. What are we really, because obviously we're going to see those launch abort engines fire. That's going to be the first that's going to kick off a really quick sequence of this pad abort.
Yeah, so absolutely. So pad abort test is really a test of Starliner's end-to-end functionality of our abort system. So, we have to make sure that we can keep the crew safe in the unlikely event that there's an emergency. And Starliner's abort system is really designed to be able to successfully abort at all phases of flight. So not just on the pad, but all the way up the ascent profile. And, we've tested this system at the component level, we've tested at the, subsystem level, and now we're testing at the integrated system performance level. So we really want to make sure that all these systems are going to work together so that we can keep our crew safe. So some of the things that you really want to keep in mind is we really want those launch abort engines to be able to propel that spacecraft away from the launch vehicle adapter that's actually right there at the pad today, filling in for United Launch Alliance's Atlas V rocket. So we've got 4 major launch abort engines, 40,000 pounds of thrust each, and we've got about a dozen or so OMACs, which are orbital maneuvering and attitude control thrusters, 1,500 pounds each. So we really want to see them propel that spacecraft safely away in the unlikely event of an emergency. The next thing you want to really look out for is guidance, navigation, and control. We really have to be in control of that spacecraft the whole time, and it's got to go in the general direction that we need it to go, right? Especially on launch day, if this were the real thing, we've got to be able to make it over to the Atlantic Ocean. And then, all of our separation events have to work properly. You got to see the parachute sequence, jettison and initiate correctly. And then really one of the other main separation events that I just want to mention for you is you're going to see the service module separate from the crew module. And that's a really critical separation event. And I'm going to walk you through an animation here in just a minute. But before I do that, just keep in mind that service module is going to separate from the crew module. It's going to free fall to the ground, and some residual propellant that's left over in that vehicle may actually ignite, and it may flame a little bit. You might actually see a colored smoke trail, but that is exactly what we expect to happen. Keep in mind, if this were the real thing, it'd be landing in the ocean, but today it's landing on the desert.
So if we see some extra fireworks today, it is expected, and that's you'll be seeing what we expect.
Yeah.
So why don't we go through the animation?
Yeah, it's absolutely expected. I mean, this is going to be a really dynamic couple of minutes. Let me take you through it here. So you're going to have those launch abort engines ignite. Those LAEs are going to fire for about 5 seconds. Those OMACs are going to continue to fire intermittently for another 5 seconds. That just gets the spacecraft in the right trajectory. And then this is all going to go pretty fast. Before you know it, the spacecraft is going to start to do its pitch around maneuver, which gets itself in the proper orientation to land. You're going to see that ascent cover and that forward heat shield jettison together, followed by the parachute sequence. 2 drogue parachutes, followed by 3 pilot parachutes. That's jobs are really just to bring out the mains. And then you're going to see 3 main parachutes deploy. And really, parachutes are really pulling double duty here, because not only are they designed to bring the crew module safely and slowly back down to the ground, but they're also being jettisoned at the proper time, or deployed at the proper time to make sure the spacecraft is in the proper orientation to properly separate that service module from the crew module. But like I said, you want to keep your eyes on that crew module because that's where, of course, our precious cargo is. About 60 seconds into flight, that base heat shield is going to jettison, and that allows for those gorgeous landing airbags to deploy. You know, keep in mind here, Starliner is going to be the very first American-made orbital crew capsule to land on land, and you're going to get a bit of a preview of that today.
That's right, and we've been out here a couple of times doing those landing tests. One of the prime landing zones for Starliner is going to be here at the White Sands Space Harbor, actually right by an old runway that the shuttle landed on one time in its program on STS-3. So a lot of exciting stuff happening today. It is important to note, I mean, this is a challenging test. We're really putting the vehicle in kind of one of the most dynamic situations it could possibly be in. You're simulating getting the crew out of an extremely dangerous situation. And at NASA, we have some pretty recent history with just how important systems like these are. Our astronaut Nick Hague just last year in October was on a Russian Soyuz spacecraft, and it aborted while he was on his way uphill, but he was able to land successfully thanks to an abort system along with his crewmate Alexei Ovchinin. So really important test here today, a really important system, but it just feeds into what we need to do to make sure when we're ready to go put crew on one of these spacecraft, they're going to be in a safe place.
Oh, absolutely. You know, I think the Boeing team thinks about that all the time. You know, we are constantly thinking about safety and how we can absolutely make sure that our crew is in the safest vehicle that we could possibly make. You know, I just want to, you know, show you some video actually from the Starliner production factory in Florida back when they were signing this spacecraft. You know, the gentleman you see signing it here, his name is Kevin, and he's one of our lead technicians. He's told me before, you know, hey Jess, if something's not right, I'm not going to sleep tonight. I'm going to come in the next day and we're going to get it right. And you know, you see here, you've got our Boeing President and CEO of Boeing Defense, Space and Security, Leanne Corrett, who is signing the spacecraft now. You can see her signing a little note to her father, who actually worked on the Apollo program. Leanne was actually born on the Space Coast, so the space heritage is in her family, and you know, the entire Boeing team is behind space in this particular program.
Yep. And we're actually hearing on our loops right now that they are going to be in a hold for a second. We're going to take a few moments and figure out what's happening, but we're still getting some great views of Starliner on its pad with that service module. So stay with us for just a couple of moments. We'll get a new updated time on what our countdown was. Yeah, and again, we are currently in a hold. We're just still standing by to see what issue the teams are working. We'll get a new T0 time to you hopefully in just a little bit. But we do have a 3-hour window today.
Yes,
so 7 o'clock Mountain was right at the start of our window, so there is plenty of time for the teams to, take it slowly, make sure they're not working any issues before we see Starliner take to the air.
That's right. And, let's go ahead and talk a little bit about that team. Our flight director for today is actually Alicia Evans. Alicia led the team through Starliner's environmental qualification testing, a campaign that, we really passed with flying colors. So we are incredibly proud of Alicia, excited to hear her on the flight loop today. And then you'll also be hearing from Jim Harder. He is our flight dynamics officer. You're going to hear him coming up here in just a little bit. Go ahead and give us all of the milestones as they happen during the test. But while we wait, I actually want to take us back and roll some video here of the team rolling out the spacecraft in preparation for launch. So this was actually, and we'll kind of give our production team a second here to kind of get that video ready to go. But, what was really incredible about this operation is it's one of the most hazardous and complicated operations that the team will do. You see the spacecraft here coming out of the FIDF, which is our test facility here on site at Launch Complex 32, and you see it roll out of that building. Now, this entire operation they started about 5 o'clock in the morning. It took them until about 10 o'clock to kind of get it up into place. But just think about it. This is a fully fueled vehicle that they're rolling out here. And I believe it was a 100-ton crane that they used to get it up onto the gantry. Wow. And then, they had to hand torque 278 bolts to get it in place. So really, really proud of the team there. They had practiced for a couple of weeks. Jeff Bertelson, who is our recovery lead for this test, was telling us about it the other day. And, they practiced with some of what we call our boilerplate vehicles, which are what we use to practice our landing, airbags, and our parachutes with. So just really proud of them, and they really got the job done.
Yeah, and the rest of the team, they've been on console since at least 10 o'clock of last night, so they've been working through the overnight hours to get everything ready for our test today. Again, we have a 3-hour window. It just opened at 7. Teams, if you're just now joining, they are taking a look at a couple of things on the spacecraft, so we're waiting on a T-0, but as soon as we hear it, we will be letting you know. But still getting some great views. We're going to have views via some tracking cameras from the White Sands folks here at Wismar. They do a lot of missile testing and things like that, so they have these cameras that can track things going very fast through the air, so it's perfect for a test like today. Yeah. And this is also going to be one of the prime landing sites, if not the prime, for Starliner once it's flying.
I got to say, the White Sands Missile Range and White Sands, they're just incredible partners of ours. The United States Army, we really could not do it without them. They're such an integral part of the Starliner team. Like you said, we've got 2 landing zones here at White Sands. This is also where we do our parachute testing right on the other side of the mountain here. In addition to that, this is where we did our service module hot fire test and, of course, our pad abort test today. So we could not do it without the U.S. Army and White Sands. They're incredible partners of ours. And from what I understand, you're pretty familiar with White Sands as well, are you not?
Yeah, we actually used the exact same stand for our Orion spacecraft's pad abort a few years ago. And I've had the opportunity to come out with the Boeing teams a couple of times now to do these practices for landing and recovery. It's really exciting. I've got some experience doing it over in Kazakhstan with the Russian Soyuz. This is completely different environment, completely different team, but it's really exciting. It's usually a little bit warmer when we're out here. I think it usually gets up around 100 during the summer because we've been out here in July and August. It's a little cooler this morning, but it's not too bad. And we haven't had any weather constraints as we heard earlier.
No, we have not. I think, it did get a little cold, so I know the team was looking at our helium tanks, wanting to make sure that they stay at the right temperature overnight. And, we do have a little bit of a wind constraints, 15 knots, but that's really just so that we can get the gantry rolled back. So the weather has been fine, and I'm really excited to watch this test happen because we're going to go about 650 miles an hour in probably about 5 seconds. There's going to be so many dynamic events happening that we're going to get data on during this 2-minute test, and I know this is one in particular that the team's really excited to see happen.
That's right. And again, if you're just joining us, we are waiting on a new T-0, so new launch time for the pad abort. Does sound like we're getting close. We're going to just pause for a moment, listen in, and then we should be able to get you that new launch time in just a moment. All right, and we are here, and we do have a new T-0 time. We're now looking at 7:15 Mountain, 9:15.
Yep, it looks like the team was just taking another look at propellant pressurization. Want to take another look at what they saw on screen, and they say, hey, you know, we're still doing okay. So we're going to go ahead and just reset to 7:15, and that is taking a look at the clock here. That is not too far away at all, is it?
Yeah, we should just be about 7 minutes away now.
Great.
From this liftoff. And again, if you're just joining, our original T0 was 7. Worked a quick prop issue. Now we're good to go at 7:15.
That's right.
If you want, why don't we show them again? Because this is going to be a really dynamic, a really quick test. As Jessica said, 650 miles an hour in just 5 seconds. So that thing's going to shoot off that pad really quickly.
Yep.
And why don't you walk us through again one more time?
Absolutely. So, and that's exactly what we want to see, right? We want to see all those launch abort engines fire with those OMACs, and we want to see that spacecraft really shoot off that launch pad. Like you said, 650 miles an hour in about 5 seconds. We're going to hit apogee here pretty quickly. I think we hit it in about 19 seconds. We're going to start to make that pitch around maneuver that just gets the spacecraft in the right orientation to open up that landing sequence. And that's initiated really by once you see that ascent cover and forward heat shield come off, that really allows the parachute sequence to begin. You're going to see 2 drogue parachutes followed by 3 pilot chutes, and that really just bring out the mains there. And again, those parachutes, they're really pulling double duty here for this test. Not only do they have extra weight of the service module attached, right, and their main job is really to make sure that they bring that crew module down slowly and safely, but in addition to that, they're deploying at a certain time that kind of pulls the spacecraft back and gets it in a proper orientation to safely release that service module. Then you're going to see, you know, that bucket handle release, like you just saw, that's also pretty critical. That allows us to, come down nicely in stable 1, which is just right on the top of our airbags. And then you would see that base heat shield jettison, which allows those landing airbags to deploy. And I got to tell you, I'm really, really looking forward to seeing that today. Our team has worked so hard to make sure we can design a system that is safe and is also one that's reusable and landing on land. These Starliner crew modules are reusable spacecraft, and one of the ways that we're able to do that is because we land on land.
Yeah, and important to add again for people, the service module is going to come off and it is going to impact the ground, and there will be some residual fuel on board that may ignite. So if you see that, it is totally expected. And as we talked about, they're going to land on land for the real thing, but if we were in a pad abort scenario on a real day, they have the Atlantic Ocean that they'd be going over, so that service module will be dropping in the water, followed shortly after by the crew capsule under the parachutes.
That's correct. And, we can talk just a little bit, too, about how the team plans to do some of the recovery after today's test is complete. So the crew module, of course, will be recovered, taken back to Launch Complex 32 for evaluation and analysis. And we really want to make sure that we get all the data back off that crew module. We are flying an anthropomorphic test dummy in there, and so we want to get all the data back from our ATD as well. And that data is really critical. So we're going to go out, we're going to recover it, we'll bring it back to the launch site for evaluation and analysis. Now the service module is a little different, and a combined team of Boeing, the U.S. Army, and an environmental and industrial services company called Clean Harbors is actually going to go out. We're going to safe the vehicle and then properly dispose of it. And I think that is going to be a process that'll take probably 2 or 3 days. We do have some data that we're hoping to get off the service module too, but I guess that'll depend on the state that it's in.
Yeah, but we're less than 5 minutes away. Again, that launch time right now is set for 7:15 Mountain, 9:15 Eastern time. In just a couple of minutes, we're going to bring up the actual launch control loop, where you're going to be able to hear the flight director and some of the other folks. Again, walk us through who are we going to be hearing on these loops this morning? Yeah,
so once again, you're going to be hearing from Alicia Evans. She is our flight director today. And Alicia, like I said before, led our environmental qualification test campaign. And that was a really critical test campaign for us, because what we do is we go ahead and we build a full spacecraft, and then we send it off to California. Our folks at El Segundo out there, they were just amazing for our environmental qualification campaign. And what we do is we shake it and bake it, is kind of what we say in the spacecraft world, where we make sure that we put it through the exact same conditions that it's going to see on orbit. We make sure that, it can handle the swings in temperature, the radiation and all of those types of things. And like I said, passed with flying colors. Alicia led that campaign. She is now leading Starliner's very first flight test. We could not be more proud of her. And then once again, you're also going to hear from Jim Harder. He is our flight dynamics officer today. So you'll hear the liftoff line coming from Alicia, and then the rest of the events in this sequence you're going to hear from Jim. So at this point, we are T-minus 2 minutes and proceeding to launch. So Dan and I are going to go on ahead and listen right on in with you.
Go Starliner.
Flight is slick. All commands are complete.
Copy that, Slick.
Stand by for final abort commands.
Copy that.
L-minus 1 minute and counting. Seconds. 40. 30 seconds and counting. 20 seconds and counting. 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
Liftoff.
Roll complete. LE cutoff. On track. OMAC cutoff. Picture on. 40 killed parachute. Broke parachutes, mains. SM7. Two mains fully disreefed. Base heat shield jettison. Airbags inflating. CM touchdown.
All right. Well, we have Starliner taking to flight for the very first time and touching down safely and beautifully on the desert floor. That was just incredible, Dan. It's kind of hard not to get a little bit emotional over here just watching it, but that was phenomenal. Initial indication is that we've had a very successful pad abort test today.
That's right. It went off, it lit off, and I mean, when you're standing here watching it in person, that thing's really moving when you see it get up off the pad. And then the sound hits you about 5 or 6 seconds later. You just get that rumble across the desert floor as Starliner's already streaking through the sky.
Absolutely. And to see it touch down like that, now you did see touchdown under 2 good mains, which is certainly within the bounds of the acceptable bounds for this particular test. We have tested with 2 good mains and qualification, and that is acceptable for our landing sequence. So this was just incredible. It was incredible to watch this test, and it was just absolutely unbelievable. We're going to take just a little look at a replay here. Again, I hope you didn't blink, because 650 miles an hour in 5 seconds, that thing sure did shoot off the test stand, didn't it? You have the launch abort engines firing, those 4 launch abort engines, 40,000 pounds of thrust off the stand, OMAX, another 1,500 pounds of thrust each on those. Those continue to fire. You saw the pilot parachutes pulling out the mains there after that pitch around maneuver, and then of course you saw the service module at some point fall away. And I mean, what an absolutely beautiful sight. Parachutes really doing their job here in terms of making sure that they can get the spacecraft in the right orientation to safely release that service module down to the ground. And of course, you know, we want to keep our eyes on that crew module. You know, I think our folks back in Florida are going to be really interested to see the data come out of this test today, for sure.
And again, we saw two out of 3 parachutes, but that is a stable condition, and that's just kind of goes into what we have in spaceflight redundancy. And if you've ever been around anyone from NASA or Boeing or any of the space companies, redundancy, we have backups for our backups, that whole thing. And that's just really a great example of how you're able to work even when things don't go exactly as they're designed.
And actually we could have, you know, our fault tolerance on that is really, you know, one drogue out as well as one main out. So we do have redundancy, like you said, built in. And it's just, again, it's just so incredible to see those landing airbags on our spacecraft touchdown. You know, it's going to be incredible to watch it on a return to mission here coming up right around the corner, December
right in the
17th. Yep, absolutely. You know, I just want to give a quick shout out to our folks at the Starliner production factory in Florida that I know are watching right now. Also our folks in Houston that are watching, and our folks all around the country. You know, they have worked so incredibly hard for this moment today, and to see a spacecraft that they built on a launch pad for the very first time just means so incredibly much. And I'll tell you what, you guys, it was just as beautiful in person as you would have, as you would imagine.
Yeah, but I mean, there it sits. We'll continue giving you some of these great views, and maybe even a couple of replays. We're going to hang out for a little bit. We know that a couple of people were here watching, including our first Starliner crew.
That's right.
So we're hoping to get them over here in just a couple of minutes and come celebrate with us.
Yeah, and you know, let me just again, you know, remind folks how we're going to be recovering the spacecraft today. That crew module that you see there, that's going to be recovered, brought back to Launch Complex 32 for evaluation analysis. Again, you know, we want to make sure we get all the data off that spacecraft. Of course, the initial indication here is that we've had a successful test, but you know, we really want to take a hard look at all the data and hand that over to NASA, and of course make sure that everything worked as well as it appeared to look to us. And the service module is going to be recovered slightly different. Like I said, that we're going to get a little bit of data off that service module if we can, depending on the condition that it's in. But a combined team of Boeing, the U.S. Army, and an environmental and industrial services company called Clean Arbors, they're going to go out. We're going to safe that vehicle, and we're going to go ahead and properly dispose of it. So really exciting. The crew module, of course, we're going to keep around, possible reuse. You know, there's of course, flight hardware on there that we could potentially reuse if we needed to. But, you know, once again, the key here is those crew modules are reusable vehicles. You know, we have 2 additional spacecraft back at our production facility in Florida. Of course, the Starliner that's going to be launching here in December for our first uncrewed orbital flight test to the International Space Station. And then we have the spacecraft that is going to launch crew. It was actually the very first spacecraft that we built, sent out for environmental qualification testing that Alicia was a part of. And we've got that spacecraft in the factory as well. In fact, you might have seen some photo of our orbital flight test vehicle, complete and fully built, and actually rolling into one of our hazardous processing areas for fueling, getting ready to roll out to the pad.
Everything's on track for Starliner's first flight to space and to the International Space Station. We've already put out some news on that. Right now we're targeting December 17th. So if you're going to be on the Space Coast around the holidays, might be a good idea to come out for a rocket launch.
Yeah, and hey, I'll tell you this, Starliner is the very first human spacecraft both built and launched right in Florida. So if you live on the Space Coast, we really hope to see you come on out and support your hometown girl and watch her fly, because that's going to be really incredible.
Yeah, there's a couple of things just coming up over the next several weeks. Starliner itself is going to get fueled up in that C3PF, that production facility where the Starliner is being built. Following that, it's going to get rolled over to the ULA Vertical Integration Facility. I'm trying to get all my acronyms right as I go
hey, you're
through
doing a good job.
ULA actually stacking the rocket today, so getting it ready. And again, we're targeting December 17th for that launch. It'll be a flight up to the space station. It'll get there in just about a day, I think, is the latest dynamics. That can change depending on where the station's altitude is over time. It'll be about a day up there. It'll dock. It'll be the first successful docking of Starliner. They'll have it there for a couple of days, and then we'll meet it right back here just a couple of days after.
Yep, absolutely. You know, it's really incredible. Taking another look here at this crew module on the desert floor. You know, very first time Starliner takes flight. Just with, I mean, I gotta say, you know, to see it come down and touch down on the desert there under those landing airbags, it just is. We're going to be making history when it does that on a return to space mission here coming up in December, like you said. But to see it today, it's hard not to get a little bit emotional. Just knowing the folks back at home who have just put their hearts and souls into this. You know, it's funny because I showed a little bit of footage of the spacecraft being signed in Florida before, and I talked a little bit about Kevin. I don't think I mentioned Jonna, who was also in that file footage. And here's a really funny fact about her. You know, her daughter actually says that the spacecraft is her younger brother, because her mom just spends, you know, so much time, the dedication that she's put into the spacecraft as one of our lead wiring technicians. And you know, it's just the Starliner production factory, folks in Florida, folks in Houston, and all across the country who've helped us out and have just put their hearts and souls into this program, are full of folks like Kevin and Jonna, and you know, really hoping that they are just grinning from ear to ear this morning and getting ready to celebrate.
And again, if you're just now tuning in, you are looking at Starliner. It's on the desert floor. That pad abort was done successfully. Our T0, so our launch time was 7:15 a.m. Mountain, 9:15 a.m. Eastern. If you didn't catch it, we'll have some more replays coming up for you, because it was over in a flash. I think it was from start to finish. It's only about a 95-second test or so.
Correct.
So it's over quick, but we got to see all of the events happen in sequence, those 4 launch abort engines firing, throwing Starliner up in the air away from the pad, and then getting it in the right orientation, pitching around using those thrusters on the side, getting good shoots or good drogues out, the service module separating.
Correct.
Everything looked fantastic this morning. 2 good mains, so still in a stable configuration.
Yep.
The airbags inflating and touching right down on the desert floor.
And like we said, those 2 good mains are certainly within the acceptable bounds of this test. Here we go. We're going to replay it again here for you. So just in case you're just now tuning in, you know, at this point, you know, you see that pitch around maneuver happen, and those as it prepares to go ahead and start the parachute sequence. You saw those look to be those 2 drogues followed by those 3 pilots. Here come the mains, and as we continue to replay that here, I'm just going to go ahead and get folks excited here, getting ready to welcome the crew flight test crew, Boeing and Starliner astronauts. They're just pulled up. We're going to go ahead and talk to them, go ahead and get them. Hey, come on in, guys. Come on over. Come on
we're
over.
Gonna get everybody. Come on over, guys.
How are you? Good to see you.
So awesome, huh?
How's it going? I know, long time no see. Okay, come on over. Mikey, come on over here with me. Right. Nicole, go ahead and get in the middle of these guys. All right. So, just an incredible test. Dan and I were out here. I know you guys were watching the test nearby. This, of course, is the Boeing Starliner crew flight test crew. We've got Boeing's astronaut Chris Ferguson, NASA astronaut Nicole Mann, and Mike Fink. And let me just start with this guy, because this is really, this here is space flight legend, Mike Fink. This will be his 4th time up to space on Starliner here, coming up on our crew flight test. But in addition to that, this is actually going to be your 3rd vehicle. So as rare as it is to be an astronaut, it's even more rare to fly on your 3rd vehicle. So what were your impressions today of today's test?
Well, today was really amazing. We hope we never need to use this system, but in case we ever have any trouble aboard the beautiful Atlas V on the launch pad, we know after today's test that we'll be able to get off safely and then come back and try again a different day. So this shows that Boeing is committed to safety, and that we are really looking forward to flying on a safe spacecraft, and today really showed it. It was beautiful.
So how's it going to feel for NASA to have a crew transport system once again?
Well, it's been a long time since we've launched out of the United States. We really appreciate our friends in Russia for having the launch vehicle on the Soyuz. I flew on it twice. It's a great launch vehicle, a great spacecraft, and but it's time to have more options. And the commercial crew program is opening up a new industry for the United States, and it's an exciting time.
Yeah, you know, I'll tell you, I know we were together over in Florida while you guys were there getting in the Starliner vehicle, and there was a moment where you were in the seat and you were kind of taking a look at the paneling, and you know, our human factor systems engineer Selena Dopart was there, and you kind of turned to her and you said, I see what you guys are doing here, and it looks good with the paneling. And I know she kind of was really moved by that comment. I was in there. I got a little choked up over it. It's just incredible to have you here and be a part of the team.
Well, thank you. I'm glad to be part of the team also.
And so, of course, NASA astronaut Nicole Mann, this will actually be her first time to space, Marine fighter pilot. So at this point, like I said, you were just out to our recovery zone for mission dress rehearsal. We saw you in Florida. Is it starting to feel like launch is around the corner at this point?
It's starting to feel really close. It's amazing, especially being here for the test. We've had a chance to be in the vehicle quite a few times, but down at the Cape last week, we were in the spacecraft and it was all finished out and all the final paneling was on, and it looks a lot like our trainers. And so that's good news. We've been going through a lot of the training, so it's nice to see the final products coming online, and big milestones like the test today are just showing that we're getting a lot closer.
And then Chris, for you real quick, so you closed out the shuttle program and then you came to Boeing shortly after. And I mean, this program has been kind of your life for the last couple of years. What's it like to now be standing here after Starliner just took to the air for the first time?
So I've envisioned what this day would look like. You know, I had this trajectory of what this pad abort would look like for a long time, and to actually see it happen was just fantastic. And it worked pretty much the way I had always envisioned. And I really have to, I gotta take my hats off to the Boeing team. You know, as we speak, of course, we have this huge test going on today. On the East Coast, we're fueling our vehicle for the orbital flight test that will take place in December. So on both coasts, we have major operations taking place to restore human spaceflight from the United States of America. It's a very proud moment for me. It should be a very proud moment for the entire Boeing team who have made this happen. And you know, hopefully our NASA customers are equally happy with the progress that we've made. And it's a great day for the United States of America.
That's right. Yeah, as a NASA guy, it was great to be out here with the Boeing team. I know we're all super excited too. Our NASA astronauts, the Boeing team, really a fantastic day. We don't want to hold you guys up too long.
That's right.
I'm sure everybody wants to start celebrating because this was a really successful day. So thanks for running over real quick and having a couple of minutes with us. Really appreciate it.
We really do.
Thanks.
Yep.
Excited to be here.
All right.
Absolutely.
Thank you.
Thank you so much, you guys.
See you guys later.
That's a TV.
That's right.
So at this point, you know, it's what's up next for Starliner, our uncrewed flight test to the International Space Station, slated for December 17th. Can't wait for that. So excited. Hope y'all all tune in and watch us. And like we said, if you're on the Space Coast, you better come on out and support your hometown girl.
That's right. And as we said, there's a couple of milestones leading up to that. Spacecraft's being fueled. Pretty soon it's going to be rolling out to ULA's vehicle integration facility, and it'll actually get stacked on top of the rocket. We're looking for that in the next couple of weeks. So stay tuned. Again, you can follow Boeing on social media at Boeing Space and on Boeing.com, and then NASA, NASA.gov, and our various social media sites, including at Commercial Crew on Twitter, Facebook, Instagram. We're everywhere. So continue following along. Thanks for waking up and watching this today. Starliner's first flight test. Its first time taking to the skies, a successful pad abort this morning.
Hey, thank you very much, everyone. See you out there.